let's start. My name is Philip, and I'm here to talk a little bit about DCs, discrete long contracts. I'm actually currently down in Australia, so unfortunately I can't be with you. But nevertheless, I hope you're going to find this so interesting. Let's start. So what are DCs? Discrete long contracts. The problem is, well, what's the problem? What problem do you want to solve? We want to solve the problem that Bitcoin has no smart contracts, right? Like there is no EVM on Bitcoin, there is no Turing complete language, and that's why we can't have nice things like DeFi, right? Right. We actually do have smart contracts. We have a very simple scripting language on Bitcoin, which might not be Turing complete, but it's powerful enough to build awesome things on, such as smart contracts, and with that, we can indeed have nice things, such as DeFi. But first, let's agree on what is actually a smart contract. A smart contract is a conditional payment which uses information to trigger a payment. And usually this information is off-chain, meaning the information is not on-chain, but it's being pushed into the chain using a third-party service like an order. Off-chain information can be like prices, political events, sport events, basically anything to trigger an event. The core idea of smart contracts is that they can be triggered unilaterally, meaning that we do not have to ask permission differently. So they are self-custodial, so that you are in full control over your own key, and you can do whatever you want with it. You don't have to ask permission. And there are different use cases for smart contracts, such as the most common ones, trading, betting, lending, and borrowing, or even voting, or gaming, and other kind of things that you can do. I like to describe smart contracts in two separate steps. And the first one is, I call it the contract setup phase, where all the parties who are participating in this contract are looking up their money in this contract. And then we have the settlement phase, the execution phase, where the winner claims the funds according to the rules in the smart contract. If you assume there are no smart contracts on Bitcoin, what would be the naive way to build why do we actually need smart contracts? Let's assume as a bot, they want to engage in a simple contract. They want to bet on a coin, they want to flip Bitcoin. And naively, what they do is they take their money and lock it up in a multisig. And that multisig is controlled by Alice and both parties need a signature. And then they send this transaction on chain and the money is locked up. Now the event happens. Conflict gets hacked, and Alice says, "Hey, give me my money." So Alice says, "It's going to be heads up." But Bob says, "No, not with me. You don't get my money." And Alice is unfortunately a bad luck because she needs Bob's signature to really get out the money. How can we solve this? We can solve this using introducing a third party, an escrow. In this case, we just call it Neo, and Alice and Bob send the money into a wallet controlled by Neo. Let's assume then the hands happen again. Alice says, "Give me my money." Bob is malicious and says, "Nope, sorry, bro." And Neo says, "I got you, bro," and sends the money to Alice. This is already a little bit better, but it's really not ideal because now you fully trust Neo and basically fully custodial, and Neo might run with the money and Alice and Bob have no chance to get the money. A little bit better approach would be to use a 2 out of 3 multisig, meaning they send the money into an output which is controlled by Alice or Bob, or Alice and Neo, or Bob and Neo. So we need two signatures to spend the money. Again, hands happened, Alice says, "Give me the money," Bob says no, and now Neo and Alice can collaboratively spend the money. The advantage of this 2 multisig is also that if Neo disappears and decides to not collaborate anymore, Alice and Bob can still collaborate with taking the money. However, if no one collaborates anymore and Alice just wants to take the money, then she might be a part of that. Same use cases, same situation if Bob and Neo group, they could both steal the money from Alice. So we really want to have smart contracts. And the naive approach, they are not market, because what we want is we want to minimize the trust. Like, we don't want to have reliable code. We really want to remove this counterparty risk so that there is no impact, and so that you can unilaterally exit the contract. Unilaterally means you don't have to ask for permission. So summarizing, smart contracts are contracts which create off-chain information which are hard to trigger a certain event. And if we don't have smart contracts on Bitcoin, then the best we can do today is to read it, which is it. But we actually do have smart contracts. So that means DLCs, discrete log contracts. Discrete log contracts have been around actually since quite a while. They've been around since 2017, and they have been proposed by Patch, who is also the co-author of the Lightning Network white paper. And the core idea is to have a monetary smart contract on Bitcoin natively, which we couldn't have before. And he describes this real law contract as a system which addresses the scalability and the privacy concerns of smart contracts on other chains, and they seek to minimize the trust required in the oracle, which provides an external data. We will see later what that actually means. And the contracts are discrete in a way that a third-party observer cannot detect that there is actually a smart contract in place in the first place. And this is improvement over existing smart contracts compared to EVM or other platforms where you have the whole contract on chain and all the data on chain and everyone knows what's happening. So DLCs are meant to be two-party contracts, meaning we have two main parties involved, let's just call it L and mod. But we also have a third party, which is an oracle, and that oracle attests to the event independently of the other two parties. And this is a trusted oracle. It's very important to understand. It is not trustless, but it's trust minimized, because you need to trust that the oracle does its job. And the oracle is nothing special. It's a very stupid service which runs somewhere completely independent of the two parties, and it's not even aware of the two parties engaging in a contract. There is also no trust in between the two parties, so that the two parties can always, they don't have to trust each other. There are two different types of DLCs. There is a binary outcome DLC, which the name already implies, where yes, no answers, and heads or tail or others, or more complex DLCs where you can have numerical outcomes, like if you want to bet on the Bitcoin price or a number of moments or something else. Let's look at the transaction structure, so that you see that there is no additional data stored on chain. Again, in the use case, kind of above, they want to bet on a coin flip. They first create an economic transaction where they both look at the money in this system. Now, important is that they do not sign this transaction yet. So when they create this transaction and prove that they have those inputs available, they do not sign this transaction yet. Instead, what they do is they create CETs, or contract execution transaction. And in the binary outcome, in a coin flip scenario, they create two CETs, one for each scenario. So there's one CET heads, which spends all the money to Alice, and one CET or tails, which spends all the money to Bob. Additionally, they create a refund transaction, which, if anything goes wrong, like if the oracle never attests to that event, or if one of the two parties disappears, they have a refund transaction, which becomes relevant after a certain time, and that returns the money to both parties. Only after all of those transactions have been signed, they sign the initial funding transaction and publish that transaction. Now they are sure that the contract is set, no one can take the money anymore without having to get a signature from the other party, and they know that if anything happens, they get the money. So let's assume the oracle attests to the contract and says, alright, it is heads. And then with this information, the oracle publishes a signature and one of those CFDs becomes valid, and in our case, Alice can take all the money. Similar to that, a little bit more complex and numerical outcome is where you have arbitrary number of outputs, possible outputs. For example, Alice and Bob would like to bet on Bitcoin US dollar price, like an option or future contract. Now, again, same as before, they create this funding transaction, and from it, they create a set of CETs. And this could be hundreds, maybe thousands of CETs, one for each possible contract. For example, if they bet on the Bitcoin price, it could be that there is one possible price for every possible price from $0 to $100,000 one contract. And you can optimize this so you don't have 100,000 contracts, but you still have quite a few contracts. Of course, they also create the refund transaction, which returns the money if something goes wrong. And after signing all of these CETs, they sign the funding transaction, and we go and the contract is signed. Now there is no other data records in the contract. Here you can see that the funding transaction, the only thing you see on chain is that it's a mixture between Alice and Bob. And if we were to use something like Schnorr-Sig or Schnorr-Sig, you wouldn't even see that as a multi-sig. And also those CETs, they are nothing special. They are a simple transaction which spans from one input to another output. And in our case, the oracle attests that the price is set at the past, and now the price is distributed accordingly. So in our case, Alice gets 0.3 Bitcoin and Bob gets 1.7 Bitcoin because almost getting the price goes up. So summarize, DOCs are actually smart contracts, and meaning they are basically efficient payments which use option information into account to trigger a certain payout. We've seen like Bitcoin price, or the core idea is that they can be triggered through the network. So each party can take and publish the CET independently of the other. You don't have to wait for the other approval. After everything is set up. They are fully self-custodial, so each party control their own keys, and it is private to a third party that no one knows that there is actually a contract happening in the first place. But smart contracts are expensive, and they are slow because you have to look up the funding transaction on chain. And in times where the block demand is high, the transaction fees might be really high, and then certain contracts they are not economically feasible because the transaction fees are just too high. The last point is that on-chain transactions are immutable. Immutable can be seen as a feature of Bitcoin, right? But sometimes you want to update a contract, and you want to extend the contract, you want to change the contract terms, you want to renew it, or maybe you want to exchange a contract, you want to sell your position in the contract. And that's not possible with an on-chain contract because it's immutable. You could update it and create a new contract, but then you want to get another on-chain transaction. Because of this, we said, alright, let's move those POCs off-chain. Let's move these contracts into a state chain, something like Lightning. And you probably all know how the Lightning Network works. Just a very quick summary, it is a state chain where two parties can transact off-chain and keep the interactions with the on-chain and so first, the funds are locked in a funding transaction, and from there, they have an off-chain transaction which they keep updating. And in DOC channels, we use the exact same idea. We have DOC channels are state channels which are on-chain channels and they have the same idea as Lightning. They are very cheap, and once the on-chain transaction has been published, you can update the contract off-chain for no transaction fees. This can be done basically immediately, you don't have to wait for any confirmations. And this works like this. We have Alice and Bob. They want to create a POC channel with each other. So to lending, they lock up this money in a funding transaction, and from there they create a buffer transaction. And from this buffer transaction, they create the CETs. If you remember from earlier, this looks very similar to what we had here. We had a funding transaction for a POC, which was spending directly into the CET. So we did the same thing. We have the same thing as earlier. The only difference is that the funding transaction here is independent of the POC. And you can see that this funding transaction is a little bit more complex than initially. But in our case, it is either A or B, as and all need to sign, and they do this when creating the CETs in the first place. So all the CETs need a signature by everyone. So that when the oracle attests to something, one of those CETs becomes valid. But they also have a backup, a revocable path. And in our case, it's via Alice and Bob plus the revocation key of X, or it's Alice and Bob plus the revocation key of X. And each party sends over all of the buffer transactions signed with this year to the other party, so that in case there's an update to that, we can punish if they are official next day. So we want to solve the problem that we can change the contract blockchain. What happens is we create a new buffer protection and then a new set of CETs. For example, it has changed the value of the price range from 50,000 to 150,000 instead of 0 to 150. We need to recreate all the CETs and then the buffer transaction. And updating the buffer transaction means you need to revoke your old trade and you hand over your old communications to the other party. And by doing so, always do not publish this called buffer transaction. If you don't publish the called buffer transaction, then the other party can punish you and take so the principle works exactly the same as in the Lightning Network, and we actually have it integrated in the Lightning Network as well, so that you could receive Lightning payments as well. The use cases for having smart contracts on Layer 2 is very simple. You can obviously have two things like smart contracts, paying a sport event, political events like the Trump events, or financial events. We could have real nice things like DeFi, derivatives such as options and futures. But you can also build something really cool like synthetic stablecoin, like stable stats, where you are stable in US dollar, but you transact in Bitcoin. That means there is no token issuer, there is no other asset, there is no other blockchain, it's just cents. Alright, I will be here without streaming the show my own solution. I'm part of 10.1 and we build decentralized finance for real on Bitcoin. We use DLCs to bring perpetual futures to Bitcoin, meaning there is no counterparty risk when you trade the perpetual futures. It's just you and your counterparty, and you don't have to trust anyone. It's fully self-custodial banking. And with this, finishing my talk, and let's move on to volume again, because there are any questions. Thank you, everyone.